Hi there, this is GCSE Physics Forces, and this is Lesson 18, Velocity Time Graphs. So the objectives are to calculate the gradients of graphs to find the acceleration, and to find the displacement by finding the area under the graph. So pretty straightforward. So first of all, the slope of a velocity time graph represents the acceleration. So here's a velocity time graph. So that might be a high acceleration, a low acceleration. A straight line is zero acceleration, obviously because it's a constant velocity. And a negative line would be deceleration. If you want to make any notes, remember to pause at any point in time. By high acceleration and low acceleration, it's a higher and lower respective, regarding each other. Right then, bit of some more notes. The area under a velocity time graph represents the distance travelled. So you might be asked to calculate the area under a graph. So in this instance, this is a triangle. And the area underneath would equal the distance travelled. And what we can do from that is a couple of practice questions. So let's move on. If you need any notes, remember to pause. So if you want to have a go at this one, just pause and have a go. Remember, the information that we've written down is that the gradient will be the acceleration, which we've done before previously, and the distance travelled would be the area under the graph. So I'll take you through the answers now. So calculate the acceleration. So the acceleration will simply be the gradient. So if we do the change in y divided by the change in x, so stop that from moving. So the change in y divided by change in x is the acceleration. And the change in y there is between 0 and 12. So change in y is 12 divided by the change in x, which is 4 seconds. So that will give us 3 meters per second squared of acceleration. And then what the distance travelled. So the distance travelled, remember, is the area under the graph. So that would be the area under the graph. So we've got, obviously, the area of a triangle is half base times height. So it's 4 times 12, and then we need to half that. So 4 times 12 divided by 2, if you put that in your calculator, that would be 24 meters travelled. Hopefully that's okay. Let's move on to another example. Let's have a go at this one then. So sketch the velocity time graph of a car accelerating from rest to 15 meters per second in 3 seconds, and then remaining at a constant speed for 1 more second. So if you want to pause and have a go at sketching that, I'm going to put the answers on, well, the answer on now. So it should look something like this. Hopefully that's okay. And what I want you to do now is to calculate the acceleration between 1 and 3 seconds, and then I want you to calculate the total distance travelled for the entire journey. So up to this point, if that's okay. If you want to pause and do that, and then I'll take you through the answers. Okay, let's have a look. So the acceleration will be the gradient for this little bit. So the gradient will be, so it's the change in y divided by the change in x. So the change in y is between 0 and 15 on the y-axis. So 15 is the change in y divided by the change in x of 3 seconds. So how many 3's go into 15? Gives us 5, and it's acceleration, so it's meters per second squared. Hopefully that's okay. Now for the total distance travelled, we've got to do 2 calculations. We've got the area of this triangle. So we can do that first. So that's 15 times 3, which is 45. And then because it's a triangle, obviously it's half base times height, so we need to half that to give us 22.5 meters. So just write that there. And then we need the area of this rectangle. So this rectangle is 1 second, and then 15 up. So 15 times 1 is 15. So we've got the 22.5 plus the 15. And that gives us a total of 37.5 meters travelled. Hopefully that's okay. Let's move on to the next one. Some more practice. So if you want to pause and have a go at this one, and then I'll show you how to calculate the acceleration and distance travelled using the graph shown below. So I'm going to go for the answers now. So the acceleration, remember, is the gradient. So let's have a look at this one. So we've got the change in y and the change in x. Now, a lot of students struggle with this one because, well, they just use the wrong numbers. So the change in y divided by the change in x. So the change in y is between 4 and 12, which is 8 meters per second, divided by the change in time between 0 and 10. So 8 divided by 10 is 0.8 meters per second squared. So that's the acceleration. And then the total distance travelled, we've got to calculate the area of these two shapes. So we've got a rectangle and we've also got a triangle. So let's do the area of the rectangle first. So the rectangle is 4 multiplied by 10. So 4 times 10 is obviously 40 meters. And then we just need to do the area of the triangle. So we've got 10 across and we've got 8 up. So we've got 8 times 10. And then obviously because it's a triangle, we need to half it. So 8 times 10 divided by 2 is another 40 meters. So the total distance travelled will be the 40 plus the 40, which is 80 meters. If you got that right, well done. Obviously the acceleration, 0.8. As you can see, I've been very neat there. So 0.8 meters per second squared, and the total distance is 80 meters. All right, let's move on to the last one. So this is the last one. If you want to have a go at it, just pause, and then I'll take you through the answers. So calculate the distance travelled over the 15 seconds and the deceleration during the final 5 seconds of the graph below. So let's find out the deceleration first. So it's the gradients, it's the change in y divided by the change in x. So the change in y is, change in y divided by change in x. So the change in y is, well, it's going from 20 down to 0, so it's minus 20, divided by the change in x, which is 5. So 5 times 20 is 4, and a minus, it's minus 4 meters per second squared. So that's the acceleration. But the question is specifically asked for the deceleration. So the deceleration is simply 4 meters per second squared. Then what we need to do is to just find the total distance travelled. So distance travelled over the 15 seconds. So we need the area of both of these. So it's just a compound shape, area of both the shapes. So we've got 20 by 10. So 20 times 10 is 200 meters. And then we've got 20 times 5. So 20 times 5 is 100. And then it's a triangle, so we need to divide it by 2, because it's half base times height. So 100 divided by 2 is 50 meters. So the total distance is simply the 200 plus the 50. So 200 plus 50 is 250 meters. So hopefully that went okay. And now you've got a thorough understanding of velocity time graphs, and the gradient is the acceleration or deceleration, and the area under the graph gives the total distance travelled. So thanks for watching, and I'll speak to you soon.